Conquering Math Olympiad sequence with a common difference. Three important formulas that we will be using in this particular topic. Number of terms in a number sequence is equal to the last term minus the first term divided by d plus 1. D is the common difference. Nth term is equal to the first term plus number of terms minus 1 into d. D is a common difference. Sum of a sequence is equal to last term plus first term into number of terms divided by 2. Let us now look at some examples. Question number 1. Given the number sequence 1, 4, 7, 10, 13 and so on, find the 15th term of the number sequence. Which term is number 55? Now we have the number sequence. We need to find the 15th term of this particular number sequence and which term is number 55. 55 is which particular term? Now let us now look at the solution. Difference. What is the difference? So here the difference is, what is 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So we have found the difference is 3. Based on the difference, we know that the nth term is equal to the first term plus number of terms minus 1 into the difference. So now we are going to use this particular formula to calculate the 15th term. 15th term is first term plus 15 minus 1 into the difference. First term is 1 here. So we are taking 1 plus 15 minus 1, that is 14. 14 into 3. We have 14 into 3, 42. 1 plus 42 is equal to 43. So we have found out that the 15th term is 43. Now we need to find out which term is number 55. (55) is equal to 1 plus n minus 1 into 3. So n is going to tell us the particular term of the number 55. Let's solve the equation. (55) is equal to 3n minus 2. Minus 3 plus 1, here we have minus 2. So 3n is equal to 55 plus 2, that is 57. 3n is equal to 57, so n is equal to 57 divided by 3, that is 19. So therefore 55 is the 19th term. Number 2. Find the 20th term of the number sequence 1, 6, 11, 16, 21. Which term is number 136? We need to find the 20th term of this particular number sequence and which term is number 136. It is similar to the previous problem. Let us now look at the solution. The difference. What is the difference that we have here? 6 minus 1, that is 5. 11 minus 6 is also 5. 16 minus 11 is 5. So we have found the difference. The next step is, using the formula, we will find the 20th term. 20th term is first term plus 20 minus 1 into d. First term is 1. 1 plus 20 minus 1, that is 19, into the difference is d. So we have 19 into 5, that is 95. 1 plus 95 is 96. So therefore the 20th term is 96. Now we need to find out which term is number 136. Nth term is equal to first term plus number of terms minus 1 into d. D is the difference. So 136 is equal to 1 plus n minus 1 into 5. Let us solve the equation. Minus 5 plus 1, we get minus 4. So 5n is equal to 136 plus 4. That is 5n is equal to 140. N is equal to 140 divided by 5, that is 28. So therefore the 20th term is 96. Number 136 is the 28th term. Question number 3. Find the 32nd term of the number sequence 3, 7, 11, 15, 19 and so on. Which term is the number 239? This is also a very similar question where we need to find the 32nd term of the number sequence and which term is the number 239. So like previously, we need to first find the difference. Let us look at the solution. Difference is 7 minus 3, that is 4. 11 minus 7, which is also equal to 4. 15 minus 11 is 4. So the difference is 4. Yes. Now we are going to find out the 32nd term. 32nd term is equal to first term plus 32 minus 1 into d. First term is 3. So 3 plus 32 minus 1 into the difference. So we have 3 plus 31 into 4. 31 into 4 is 124. 3 plus 124, 127. The next step is we need to find out which term is the number 239. So using the formula, nth term is equal to first term plus number of terms minus 1 into d. So 239 is equal to the first term, that is 3 plus n minus 1 into 4. Let us solve the equation. 239 is equal to 3 plus 4n minus 4. 3 minus 4 is minus 1, so 4n minus 1. 4n is equal to 239 plus 1, that is 240. So 4n is equal to 240 and n is equal to 60. So 239 is the 60th term. Question number 4. The fourth term of a sequence with a common difference is 16. The eighth term is 28. Find the 12th term. So here we have the fourth term as 16, the eighth term is 28. We need to find the 12th term. The fifth, sixth and seventh term we don't know. We just know the fourth and the eighth term. Let us look at the solution. 16 dash 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 28. 16 is the fourth term, 28 is the eighth term. What is the difference? 28 minus 16 divided by 28 is which term is 28? It is the eighth term. So therefore we have given here 8 here and 16 is the fourth term, so divided by 8 minus 4. So 28 minus 16 we have 12 divided by 4, that is 3. So the difference is 3. So 16 plus 3 is 19 plus 3 is 22 plus 3 is 25, 25 plus 3 is 28. So the difference is 3 and it is right. So when we go on doing that, when we keep on adding 3, we get the 12th term as 40. So the answer is 40. Question number 5. The first term of a sequence with a common difference is 3. The 51st term is 203. Find the 100th term. So we have the first term is 3, the 51st term is 203. We need to find the 100th term. Let us now look at the solution. Three is the first term, so we have 3 here, and 203 is the 51st term. We need to find the 100th term. We have many terms in between. Difference is what? As we saw earlier, 203 minus 3, and 203 is the 51st term and 3 is the first term. So 203 minus 1 divided by 51 minus 1, that is 4. So difference is 4. So 3 plus 4 we have 7. So after 3 next term will be 7. It goes on and on and on. We need to find the 100th term. So it will be difficult to keep adding 4 every time. So we find out this particular formula. Nth term is equal to first term plus number of terms minus 1 into d. So we need to find the 100th term. So 100th term is equal to 3 plus 100 minus 1 into 4. Let us solve the equation. 3 plus 100 minus 1. We are going to take 4 and do the distribution. 4 into 100, 400 minus 4. 4 minus 4 into 1, 4. 400 minus 4. So we get 399. So 100th term is 399. Question number 6. Compute 1 plus 2 plus 3 plus the number of terms in between plus 200. So we need to compute this particular number sequence. The first term is 1, the last term is 200. So using the formula that we have already learned, we can solve this particular sequence. Let us now look at the solution. So sum of the sequence is equal to first term plus last term into number of terms divided by 2. So the number of terms is 200 and sum of the sequence is equal to 1, that is the first term, last term is 200. So 1 plus 200 into 200 divided by 2. So So 1 plus 200 is 201 plus multiplied by 200 divided by 2, that is 100. So we get 20,100. So therefore the sum of the sequence is 20,100. Question number 7. Compute 1 plus 2 plus 3 plus a number of terms in between plus 98 plus 99 plus 100. So here also it is a very similar question where we know the first term is 1, the last term is 100. We need to compute this particular number sequence. Let us now look at the solution. Sum of sequence is last term plus first term into number of terms divided by 2. So that is the last term we have is 100 here. Yes, 100 is the last term here, and we have the first term that is 1. So now using that we are going to solve this particular number sequence. 100 plus 1 into 100 divided by 2, that is 101 into 50. We get 5050. The sum of the sequence is 5050. Question number 8. Compute 1 plus 3 plus 5 plus 7 and a number of terms in between plus 97 plus 99. So here we have the first term as 1, the last term as 99. So using the same formula we'll solve this particular number sequence. We need to find the number of terms in the sequence. Let us now look at the solution. Sum of the sequence is first term plus last term into number of terms divided by 2. So here the number of terms is going to be different. So we need to use the formula for number of terms in a sequence. Last term minus first term divided by difference plus 1. And here we can see the difference is 3 minus 1 is 2, 5 minus 3 is 2, and 7 minus 5 is 2. So therefore 99 minus 1, that is the last term, minus the first term, that is 1, divided by 2 plus 1. And when you solve the equation, 98 divided by 2 plus 1, so 49 plus 1, that is 50. So the number of terms in the sequence is 50. Now using this number of terms we will solve the number sequence and find the sum of the sequence. Sum of the sequence is 1 plus 99 into number of terms, that is 50, divided by 2. 100 into 50 divided by 2, that is 25. That is equal to 2500. Sum of the sequence is 2500. Question number 9. Compute 1 plus 2 plus 3 and a number of terms in between plus 99 plus 100 plus 99 plus 98 plus, and it goes on and on and on, plus 3 plus 2 plus 1. Now this is a different kind of a number sequence, and let us now look as to how to compute this particular number sequence. Let us now look at the solution. Sum of the sequence is first term plus last term into number of terms divided by 2. So we have two sequences here. So sum of the sequence 1 is 1 plus 2 plus 3 plus what is the sequence 1? Which is 1 plus 2 plus 3 and on till 100. So the first term is 1, the last term is 100. The first term is 1, the last term is 100 here. So when you're going to solve using the formula, 1 plus first term plus last term into number of terms divided by 2. So we have 5050. And what about the sum of the sequence 2? Sequence 2 starts from 99 and it goes on till 1. So 99 is the first term and the last term is 1. So using the same formula, when you find the sum of the sequence, we get 99 plus 1 into 99 divided by 2. So we get 4950. So the entire sum, when you add both the sums, sum of sequence 1 and sum of sequence 2, it gives us 10,000. So the sum of the sequence is 10,000. Question number 10. Find the value of 7 plus 15 plus 23 plus the number of terms in between plus 767 plus 775 plus 783. So this particular number sequence, we need to find the value of this particular sequence. So it starts from 7 and ends with 783. So the difference between 15 and 7 we need to find out. So let us now look at the solution. Sum of the sequence is first term plus last term into number of terms divided by 2. So first step here is we need to find the number of terms. Number of terms is last term minus the first term divided by the difference plus 1. So we have the last term as 783 and minus the first term, which is 7, divided by 8 plus 1. The difference is 15 minus 7 is 8 and 23 minus, so 15 minus 7. 15 minus 7 is 8. 23 minus 5 is also 8. The difference is 8. So using the difference, we have got your 8. So when we solve this particular equation, we get 783 minus 7, 776 divided by 8 plus 1. 776 divided by 8 is 97 plus 1, that is 98. So number of terms is 98. Now we have found out the number of terms. Let us find the sum of the sequence. Sum of sequence is first term, that is 7, last term 783 into the number of terms 98 divided by 2. Let us solve the equation. 783 plus 7, 790 into 98 divided by 2, 49. So we get 38,710. So therefore the sum of the sequence is 38,710. Question number 11. List the 8 numbers between 4 and 40 in a sequence of 10 numbers with a common difference. So here we know that the number of terms is 10 because it's a sequence of 10 numbers and with a common difference. We need to list the 8 numbers between 4 and 40. Let us look at the solution. First number is 4 and the last number is 40. We have already have that from the question. And the number of terms is 10. Difference, what is the difference? Difference is 40, right? 40 minus 4. 40 is the last number minus the first term. Last term minus first term divided by 10. 10 is the 40 is the 10th term and 4 is the first term. So therefore difference D is 40 minus 4 divided by 10 minus 1. So when we solve this particular equation, we get 40 minus 4, 36 divided by 10 minus 1, 9. So we get 4. Difference is 4. So 8 numbers between 4 and 40 are 8. 8 plus 4, that is 12. 12 plus 4, 16. 16 plus 4, 20. And so on till 36. That will be the 8 numbers between 4 and 40 with the difference, with the common difference 4. Question number 12. Find the sum of all odd numbers from 1 to 100 that are not divisible by 11. So here we need to find the sum of all the odd numbers from 1 to 100 that are not divisible by 11. Let us now look at the solution. The numbers that are multiples of 11 are 11, 22, 33, 44, 55 and so on till 99. So till 100 these are the multiples of 11. Now we need only the odd multiples. So some of the odd multiples is 11, 33, 55, 77 and 99. These are all odd numbers. The rest are even. 22 is even, 44 is even, 66 is even, 86 is also even. Sum of odd multiples is 275. First here we need to find the number of terms in the number sequence. So here we are using this particular formula that we already did. Last term minus first term. Last term is 99. There is a first term is 1. So the odd number starts from 1 and it goes on till 99, right? So after 1 we have 3, then we have 5, then we have 7 and it goes on and on. So difference between the numbers, if you see, it is 2. So therefore here we have D as 2 here. When we solve the equation we get 50. So number of terms is 50. Now based on this we are going to find the sum of the sequence, which is the first term plus last term into number of terms divided by 2. The first term is what? The first term is 1 and the last term is 99 into number of terms is 50 divided by 2. So that will give us the sum of all the odd numbers, that is 100 into 25 and 2500. But we need only those odd numbers that are not divisible by 11. So those that are divisible by 11 we have 275. Not divisible by 11 we need to subtract 275 from 2500 to get the odd numbers that are not divisible by 11. So we have done that and we have got the answer as 2225. Question number 13. 20 school teams took part in the West Zonal Table Tennis competition. Each team was to play exactly one match with another team. How many matches were played altogether? 20 school teams took part in the West Zonal Table Tennis competition. Each team was to play exactly one match with another team. How many matches were played altogether? Let us now look at the solution. The sequence of matches goes on like 1, 2, 3 until 19 because each team is playing with another team. So it goes on till 19. So sequence of matches will be 19 matches. Number of matches will be 19. The sum of the sequence is equal to first term plus last term into number of terms divided by 2. First term we know is 1 and the last term we have is 19. And the number of terms, to find the number of terms, we are using this particular formula, last term minus the first term divided by d plus 1. The last term is 19, the first term is 1. And what is the difference? 2 minus 1 is 1, 3 minus 2 is 1, so the difference is 1. So when we solve the equation, we get 18 divided by 1 plus 1, 18 plus 1, that is 19. So the number of terms is 19. Sum of the matches sequence will be first term, that is 1 plus 19 into 19 divided by 2. So that is 20 into 9.5. So we get 190. So therefore 190 matches were played all together. Question number 14. The sum of 6th and 7th term in a sequence of 12 numbers with a common difference is 15. What is the sum of the number sequence? The sum of 6th and 7th term in a sequence of 12 numbers with a common difference is 15. What is the sum of the number sequence? Let us now look at the solution. Number of terms is 12, which is given in the question. It's a sequence of 12 numbers, so number of terms is 12. Sum of the sequence is what? First term plus last term into number of terms divided by 2. So what is going to be the first term and last term? So here what they've already given is sum of 6th and 7th term. The 6th and 7th term, the sum of those two is 15, which is being given in the question. The sum of 6th and 7th term is 15. And then 5th and 8th term also, the sum will be 15. So the sum of the sequence will be equal to first term plus last term into number of terms divided by 2. First term plus last term, it's going to be 15. Because 5th and 8th term is 15, 6th and 7th term it is 15. So the first term plus last term, it will be 15. 15 into 12 divided by 2. So when we solve a particular equation, we get 15 into 6, that is equal to 90. So the sum of the sequence is 90. Question number 15. Place 3 numbers between 12 and 60 to make a sequence of 5 numbers with a common difference. Place 3 numbers between 12 and 60 to make a sequence of 5 numbers with a common difference. Let us now look at the solution. First number is 12 and the last number is 60. We need to place 3 numbers between 12 and 60. Number of terms is given as 5, right, to make a sequence of 5 numbers. So we need only sequence of 5 numbers. So let us look at the difference. Here we have last number minus the first number. The last number position is 5th term, 12 is the first number, the position is 1. So when we find the difference, 60 minus 12 divided by 5 minus 1, that is 48 divided by 4, that is 12. Difference is 12. So 12 plus 12, that is 24. 24 plus 12, 26. 26 plus 12, 48. So these are the 3 numbers that we can place between 12 and 60. And they are having a common difference of 12. Thank you. Have a good day.